So today we're talking about functions. Again, this is our second day. In our previous lesson, we determined whether a relation is a function or not a function. Now we're going to take a look at how to find functional values. So again, just restating what we learned last time, a function is a relationship where each element of the domain is paired with just one element of the range. And any equation that is a function can be written in a form that we call function notation. So if you notice, our equation here states y equals 3x minus 8. Function notation, it's saying that f of x, or the function of x, equals 3x minus 8. And what we'll find out is, as we put a value in for the x, which is our y value, the function of x, if I put in a negative 3, I would end up putting a negative 3 in where we have x. And then we call that function notation. So x is the independent quality, or the elements of the domain. F of x would be the dependent quality. And so here we get back to our terms as we're graphing independent and dependent. Again, using science terms, it's manipulated in the responding variables. Okay, so as we work through function values and finding it, I'm going to come back to this form, and it's easy to call it an equation. It's a function at this point because we're talking about the f of x. And so the function such that, or the function of negative 2 is going to equal 2 to the negative 2, or 2 times negative 2 plus 5. And so what we did is we substituted the value that we're finding in for x. Okay, and so we end up with negative 4 plus 5, and we find out that we have negative 4 plus 5, that ends up being 1. And so it's very similar to solving an equation. In fact, it's just like solving an equation, but now we're calling them functions. And these have implications later on in math, and it's just learning to work with a slightly different form of something that we already know how to do. So now I'm going to find the function of 3. So we use this formula again, or this equation, 2 times 3 plus 5. And that's going to equal 6 plus 5, or 11. So when the function is 3, or the y value is 3, I guess when we put in 3 for x, our output is 11. And this is really just like a function machine that you used back a while ago, where we're saying, okay, 2 times something plus 5. And in goes 3, and we run it through the equation, and out comes 11. Okay. Here we have a slightly different version of it. So we have the function of 1 plus 4. So taking a look at that, I'm just going to use what I have typed up already. It's going to equal 2, for the x, I'm going to put in the 1, times 1, plus 5. So I have to use this, and then it's telling me again I'm adding 4 to the end of that. So now I just solve, and it's 2 plus 5 plus 4. That will end up with 11 for this particular function. So here's a handful for you to go ahead and try. Again, in all of these, you're coming back to this first function and inserting different values. So for the function of such a 2, we get 4 times 2 minus 5. That's going to equal 8 minus 5, which is 3. For c, when we're putting in c for the x value, we just go ahead and put c in there, and we end up with 4 times c minus 5. And then our last one, the function when negative 3 is our x value, ends up being 4 times negative 3 minus 5. My apologies, we ran off the board with this one. Slide it back over. So that's going to equal negative 12 minus 5, which equals negative 17. Okay, and sometimes we'll see different formulas written this way. So the function h of t equals negative 16 times t to the second plus 68 times t plus 2, where the height of a football is represented in feet, which is t, seconds. T is our time after it's kicked. Find each value. So 4 seconds after a football is kicked, we're going to go h of 4, and I'm going to use this up here, equals negative 16 times t squared. They're telling us t is 4, plus 68 times 4 plus 2. Now we can go ahead and just simplify. That's going to be 272 plus 2. And then we have negative 256 plus 272 plus 2. And once we combine all of these terms, we end up with 18. So in this particular one, it's 18. Our next slide's very similar, but they're saying, okay, what if we use 2 times the function of g? So this one's slightly different. So 2 times the function of g. So I'm going to go 2 times everything inside the brackets. And where I see t, I'm inserting not a number, but I'm inserting g instead. So we have negative 16 times g to the second plus 68 g plus 2. At this point, we need to distribute the 2 through to all the terms, and we end up with negative 32 g to the second plus 136 g plus 4. And as I look at this, there are no like terms to combine, so I'm done at this point. So here, go ahead and substitute the values that they give you, and have a go at it and check your work. So in this one, we put 4 in where we saw t. 4 to the third is 64. 2 times 64 is 128. On to our next one. We're going 3 times the function when x is t. So again, here I'm putting a variable in, and it's going to end up looking like, oops, forgot 3 out in front. 3 times 2t to the third. Go ahead and distribute that through, and we end up with just 6t to the third. Give you a second to take a look at that. And that's our lesson for the day. Hopefully, I know this can be confusing the first time we come through it, but as we work through, we tend to get more comfortable. If you have questions, please bring them to class and we can go through them. And that's our lesson for the day.